So in this video, I'm going to be tearing apart this Supermicro C512 1U server as a demonstration to show each part of what a computer will look like. This is a small form factor machine, so you might come across different parts and pieces, but generally they're going to fall under the same generic hook, the same way that they're going to be hooked up and put together and that kind of thing. It's just a matter of finding exactly where it might be on that particular board or in that particular system, because all systems are different. So if we take a look at this server here, you're going to see a couple of pieces, like I said, that are going to be smaller than what you might find in a general computer. For those who have built a computer or have torn apart a server or a tower before, this is going to look a little bit different. However, the concept still remains the same and how everything is put together and built. So on the right hand side here, you're going to have your power supply. You might find something, I'll pop up a picture of something else that you might find in this place that might be a little bit larger. However, this is specifically a 1U power supply for the server, and that provides, I believe, up to 300 watts, which into different voltages to different parts of the board, and then to the hard drive, this SSD here, and then anything else that might be hooked up, like the fan, which passes through the motherboard. So moving on, we're gonna move from right to left. A little counterintuitive, but we're just gonna roll with it. So this is the motherboard. This is particularly a server motherboard. Generally, the differences are generally in the chipset and the CPUs that they can handle. For example, server motherboards might be able to handle AMD EPYC CPUs, which are particularly server CPUs, or Intel Xeon lines, which is Intel's version of server CPUs, and they're just basically, they're vetted, they undergo more testing, and they're higher quality silicon, which help to protect companies' data and infrastructure and make sure that they have the highest quality of service at all times. On that board, you're going to find memory modules. These are called DIMMs, and this is I believe a 4 gig stick of DDR3 ECC. So DDR3 is just the versioning of the memory. Essentially, we're up to DDR4 at this point. Basically, it just means increased speed and improved efficiency amongst applications that need to access the memory, such as like any programs you might be running on your computer. This server, in my case, serves as a firewall, and the CPU in this server requires ECC memory as a way to prevent any sorts of instructions being flipped or causing errors, which can actually corrupt data when it's being read from memory. So that is generally where that lies. Moving up just a little bit, you're going to see these connectors up here. This connection right here is a 20 pin. They are either 20 pin or 24 pin. And generally that's what provides all power to the motherboard. It provides up to 75 watts to the PCI Express, which I'll get into in a moment. And it also provides the voltage for the RAM and also any sorts of peripherals that might run on it. So for example, this USB port right here, if I were running something through that, or the USB ports in the back, or any of the fan ports or external ports that are linked to the outer part of the case. Due to this being a server, there is no front I/O, so there is no front USB ports or microphone or headphone jacks or anything like that. So I'm going to go and pop off this cooler real quick, and I'm going to show you what the CPU looks like. Just give me a few minutes. Okay, so underneath the CPU cooler, we're going to find the CPU. So let me just take this guy off. What you're going to find on the CPU cooler is a layer of thermal paste. This acts as a thermal conductant so that the heat between the cooler and the CPU can pass evenly, as there are manufacturing imperfections on the die, or the heat spreader, and also on the cooler plate here for the CPU, that can cause, if they were just metal on metal, they can cause inefficiencies and actually cause the CPU to overheat, and used to be able to kill themselves because there was no thermal limiter built into the CPU. So this here is called the socket, and what that essentially is just where the CPU will live. If you give me 2 seconds, I'm going to pop out the CPU. It just comes up like this. You just lift up this retentioning bracket, and then, hold on a second, once I get this situated, I can just go in by the edges and grab the CPU and pick it right out of the socket. Now, this is what the CPU will look like. That's the bottom side of it, which is just a bunch of traces that trace the different parts of the CPU underneath the heat spreader. There's a main chip, which this one in particular has 4 cores and 8 threads, which essentially means that it can process multiple applications at one given time, or one application can utilize multiple cores, basically making it more efficient and also faster. So I'm just going to set down the CPU real quick. So in the socket, one thing you're going to notice is that there's little tiny pins. Let's see, I don't have a flashlight on me, but basically in an Intel socket, there's going to be pins which connect with the traces on the bottom of that CPU. Now, in an AMD environment, in regards to their desktop line, they use a different way of pinning out the CPUs. So it's actually reversed. So the traces are in the board and the pins are on the CPU. So this here is called LGA, and don't ask me what that stands for because I don't remember, but essentially that just basically means that the pins live on the board and then the traces live on the CPU. And then I believe PGA is when the CPU has traces that live on, or when the CPU has the pins on it and then the traces live on the motherboard. So let me just pop this guy back in here. So up here on the left-hand side, you're going to have these slots, and these serve as PCIe slots. And what you can do with this is you can add expansion cards. For example, you might have like a GPU, so like a graphics processing unit, where you someone who's gaming or doing CAD work would put something like this in, and it's the same. It's in this server you probably wouldn't put something like that in there. However, if you had like a workstation or a desktop computer, generally you're going to put something in there if you're doing any sort of graphically intense work. Here, let me just up the brightness in the room here. So that's what's going to happen with those. You can also put like extra network cards and network ports into this. So if it was functioning like how I have it functioning as a router, or in a firewall, you can put more ports in the back to do separate networks or to do bonding if it was like a data server, and create basically a larger pipe for data to flow through it. And that kind of goes out of the scope of this in particular video. But if you do have questions on it, feel free to reach out and I can kind of instruct you on what every part of that is. And maybe I can even do a video on networking when we get to that unit. So that's PCIe in a nutshell. There's an older version of it, which is PCI. And basically all that is that the slots were inverted and it could only handle up to 70 megabytes a second over the bus. Generally, you're going to be limited by the CPU on how many lanes are available. Generally, in this case of this CPU, it is limited to, I believe, 20 lanes. So, no, 16 lanes. My apologies, I misspoke. It's limited to 16 lanes over the PCIe bus. And then 4 lanes get split off into the chipset, which I'll talk about that in a minute here. So the chipset is kind of like the north and south bridge now. They've kind of moved away from using north and south bridges. and just one generalized chip that handles all the processes that the north and south bridge used to do. So for example, you're going to see these two SATA cables. I'm just going to take out the SATA cable here so you can get a closer look at it. And essentially all it is it's an L. It's a keyed L connector that you'd use to hook up like a drive, particularly a 3.5-inch drive or a Sata Ssd. There's also an older standard, which I don't have a board lying around, I don't believe, that has it, called IDE. And it's essentially, it's about the size of the PCIe expander, or the PCIe slot here. But the difference is that it looks like, it has very small pins, kind of similar to this here, but it's in an enclosed capsule. What I'll do is I'll put up an image of what an IDE connector would look like, both the female end and also the cable end. Or sorry, the male end and also the cable end. So this, so any traffic in terms of SATA connections is going to pass generally through the chipset. Occasionally you might find it in modern day CPUs where they will have some direct SATA connections running from the CPU through traces to the pinouts here, or the connectors here. And that just basically, that's one way that they've tried to reduce latency in some applications, but not all applications are. It's not always beneficial. It's sometimes just easier to plug it into any port, and the amount of latency you develop from that is very limited. I only have two more things left here, and this is just basically the this is a SATA SSD. So give me 1 second here. I'm going to unplug it, and I'll walk you through basically what that means, if I can get it unplugged. Wow, that thing's stuck in there. 1 second. There we go. So SATA this is the interface for SATA. So the left side here is going to be the power pinout, and that sends 5 volts over the connector, which I'll show you in a minute. And then this is the male side of the SATA connector, which is basically the same as what's on the motherboard. And you just basically connect one end of the data connection to the drive and the other end to one of the ports. So that's a 2.5-inch SATA SSD. Now there's also a very popular version of this, and then this is a 3.5-inch drive. This is an old Samsung drive that's been dead for years, but it's same pin out, right? So it's got the SATA connections, and this passes. Both of these pass data at rates of 6 gigabits a second, which is basically the limit of what SATA can do over the cable. If you're looking for something faster, you're generally going to find something like Nvme, which is essentially an SSD that's no bigger than a stick of gum. I have one that I will post a picture over top of the video here of what that is, so that you can understand the different types of technology you might be dealing with. Now, there's also a similar connector to SATA, right? So the similar connector is going to be called, SAS. And this goes beyond the scope of the tutorial, but generally you're going to find SAS in like enterprise-grade servers, particularly data servers or disk shelves will have SAS connections. And what a disk shelf basically is basically a 4U rackable, four-unit rackable enclosure that you can slide drives in to increase storage capacity for a network for a company. And then, so this here is going to be the connector that powers the drive. This is the SATA power connector, and that just runs directly into the power supply And then you also might run into, with an IDE drive, this is a Molex connector. And these have been basically rolled in obsolescence. However, due to, in some work cases, you might find like a USB expander for PCIe might run on a Molex connector, or you might find something off. Okay, so this is the I/O of the server. So right here, this is your power supply. This is the back side. So you're gonna have a fan that draws air in to keep the capacitors and transistors cool, which is very important, and especially in maintaining power efficiency in a data center that could easily be anywhere between 85 and 90 degrees on a given day. That's the C36 connector, which is the power connector for the server, and essentially that's pretty much standard these days. You hardly find anything else unless you're dealing with maybe a proprietary server that might have its own just dedicated cord rather than having an external power supply. Those are very few and far between though. Next thing you're going to have, these are called Ps2 ports. Ps2 is essentially just a old standard driverless, a driverless standard, which basically just means that I can plug any keyboard and mouse with those connectors on it, and it should work out of the box, no problem. I don't need any sorts of USB drivers to make sure that the mouse and keyboard work. Next, you're going to have a network port. In this case, this serves as an IPMI port, or it's basically a management port, so I can log into the BIOS on this machine and make any changes without actually having to be plugged in and looking at a monitor on this computer. It just plugs directly into the network. And then obviously these are two USB ports. These are USB 2 speeds. I'll show you a USB 3 port. It's basically the same. The only difference is a lot of times they'll be differentiated by color. Usually the interior of this connector is black, which is USB 2, and then you'll find blue connectors, which are USB 3. And there's different shades of blue to differentiate the speeds. So I think dark blue is 5 gigabit USB 3.0. They've changed the branding so many times I can't keep it straight. And then USB 3.1 10 gigabit is like a turquoise blue, and then USB-C 10 gigabit has a black internal, but it looks, it's basically like a circle port on the bottom of like a Samsung phone. All right, it's actually more like an oval, my apologies. This here is a console port. You're not really gonna run into these unless you're in a data center. Nowadays, many computers don't include this anymore. This was basically a way to manage the console and command line easier than having to be connected directly over VGA, which is the next port here. VGA is a video standard that has been around for basically the dawn of computers, modern day computers, and it just basically it's an old connector that many times you'll find in the data center because KVMs or keyboard video mouse systems still use this port, and many servers still put this port on here because it's just cheaper and easier to manufacture. And then these are also two network ports that run at gigabit speed, and essentially gigabit speed is 100 megabytes a second over the cable, as long as the cable and the client side can support that. So that is a basic tour of this Supermicro C512 server and what it can do.